Now, as I mentioned, we can have more complicated things. We can have different kinds of things. So let me start with one here. And this time I'm going to write it as an integral to start with. I'm going to say, what if I have, well, looks like marker switching time. Go to blue. Okay, we have the integral of minus 2x squared plus 18x minus 6 all over x cubed minus x squared minus 6x. Now again, if that starts out as the integral, I look at that and I say, good grief, I don't have any idea what to do with this. But I take a step back and I say, I look at this thing on the bottom. Certainly that's factorable. For one thing, I can see that an x can come out of there, if nothing else. But also I look at that and I say, well, you know, I need to check the the degree, and the degree is lower on the top than the bottom, so I can't do long division. But now I move to what can this factor into? So for the moment, I put the integral out of my mind and I say, this is all I'm concerned about is, where did this come from? And I look at that and I say, well, how does that factor? Well, a factor, an x comes out clearly. And further, that part, x times x gives me x squared, minus 3 and plus 2 give me minus 6, and then the minus 3x and plus 2x will give me minus x there. So that's what that part factors to. So now I have three factored terms. I would say I've got a over x plus b over x minus 3 plus c over x plus 2. Now, that's going to be more complicated. I'm going to end up with three equations and three unknowns instead. However, I do the same basic approach. Now, there is a shortcut, and I'll talk about the shortcut subsequently, but for right now, we're going to do it just the same way we did it before. That means that in order to get a common denominator, a is going to need to be multiplied by both x minus 3 and x plus 2. b is going to need to be multiplied by x and x plus 2, and c is going to need to be multiplied by x and x minus 3. So, and again, just trying to reduce the amount of work we have to do. Once that happens, they're going to have a common denominator. The numerator plus the numerator plus the numerator will all be on the top. The denominator will be the same as the denominator over here. So I'm going to kind of forward through some of that stuff and say, okay, the left-hand side numerator is going to be this. And it's going to be equal to the right-hand side numerator, which is going to be a times each of these things, plus b times the x and the x plus 2, plus c times the x and the x minus 3. And of course I can distribute that and get these terms. And I have ax squared minus, and this gives me x in the middle, so it's going to give me minus ax minus 6a. Over here I get plus bx squared plus 2bx. And over here I get plus cx squared minus 3cx. Now, again, I look at what I have over here. I look at what I have over here, and what I'm going to end up with, now I have an x squared term as well, so there's going to be one equation that's going to be related to x squared, one equation that's going to be related to x, and one equation that's going to be related to a constant, or we could say x to the 0, x to the 1, x to the 2. So my x squared equation, what do I have? On this side I have nothing but negative 2. On the right hand side I have a plus b plus c. For my x equation, what do I have? On the left hand side I have 18. On the right hand side I have minus a plus 2b minus 3c. For my constant equation, on the left hand side I have minus 6. On the right hand side, well, I got constant right there, minus 6a. Here, well, I don't have a constant there. Here, I don't have a constant there either. All right? Because I was multiplying by x there, I ended up getting an x in each term. So I have three equations and three unknowns, but really one of the unknowns is very obvious. A is equal to 1 based on this equation right here. If A is equal to 1, then those other equations become simpler too. If I look at what that does to this equation, it's going to make that a 1, which I can subtract from either side, and then I'm going to end up with negative 3 equals B plus C. Same thing here. That's going to be a 1. It's a negative 1, so I'm going to take out the other side. I'm going to have 19 equals 2B minus 3C. And we have a system now of 2 equations and 2 unknowns where we already know A is equal to 1. And when I look at this, and again, there are various techniques for solving this, but what I would prefer is I would say, well, I want to get rid of either B or C here. If I was to multiply this equation by 3 and add them together, then the C's would go away and I'd be able to get B, and then I can come back and get C. So I'm going to do that. I'm going to do it down here. And minus 9 equals 3B plus 3C. I add those two, I get 10 equals 5B. That tells me B equals 2. I know A and I know B. And if we go back to this very first equation here, and just to kind of try to keep things a little bit separated here, I'm going to switch over to red because the blue is getting very all-consuming here. Minus 2 was equal to A, which is 1, plus B, which we've just decided is 2, plus C, and I can then say, well, subtract 3 from each side, get C by itself. I'll have minus 5 equals C. That means this equation right here, this rational expression can be rewritten as 1 over x plus 2 over x minus 3 minus 5 over x plus 2. And as before, if that's what that can be rewritten as, each one of those is going to integrate as a natural log. And so coming back to the integral that I had here, this would be the integral of dx over x plus the integral of, I'll bring the 2 outside, dx over x minus 3 minus 5 times the integral of, I'm going to pull the 5 outside, dx over x plus 2. And each of those is a natural log. So I end up with natural log of x plus 2 natural log of x minus 3 minus 5 natural log of x plus 2.